Hi, this video is going to cover exactly how routing works in a .NET Core. So we've seen our controllers in .NET Core and exactly what happens and how that serves up models and views. So exactly what's going on in the background is what this PowerPoint is going to cover. So it should have already been discussed in Chapter 1. So if you've already read through Chapter 1, there should be somewhat of a review. But I want to cover it explicitly, so let me go ahead and exit out of this title slide. I just want to cover a few of the slides just to cover some high points here to clear up any confusion. So everyone should have seen something like this in one of their courses. This slide could really be used in multiple courses. So whether it be a SQL Server course or anything like that, we have different things that consume our application. So whether you're on a computer, you're on a tablet, you're on a smartphone, so you're going to access the internet, and then from the internet is then going to access, if you're using a web browser such as Chrome or anything like that, through the internet and through wiring and networking and routers, you're going to then access the web server. So you could be going to google.com. It's then going to go through a lot of routing. It's going to figure out where the nearest google.com is. It's going to turn that web address from plain text into some sort of IP address, and it's going to figure out where that IP address lives and the fastest way to get to it. That way it can then go to the web server and then figure out exactly which application is on that web server, and then return back or serve to you the web page that you're requesting. So when we're talking about ASP.NET applications, we're talking about an application that sits on this web server. So what kind of web server it is, or what type of web server it is, usually depends on what underlying technology it's built upon. So if it's Java, that underlying web server might be a Linux server that has some sort of application on it, such as Tomcat or JBoss or Wildfly or something like that that hosts that Java application, or that Java application can run in that virtual machine. So with .NET Core, it's a little bit different than Java, obviously. So with .NET Core, or with .NET Framework, usually this web server had to be a Windows server, and so we've talked about that a little bit in this class. Usually, if it was a .NET application, it had to be run on a Windows server, which is definitely more expensive than a Linux server or Unix or whatever the case may be. So that's why that's why Java became so popular in all these open source technologies, because they could run on Linux, they could run it cheaper, more efficiently, they could spin up more boxes, they could load balance it cheaper than having to put it on a bunch of Windows servers and pay for a lot of Windows licenses. So what .NET, or what Microsoft wanted to do, was be able to make a core framework and have that be able to run on a Windows server. So if you're still on a Windows platform, or you could then use a Linux server as well to run it on, and then we'll figure out later that you can do that with a web technology called Kestrel, which is essentially a reverse proxy. So if you're familiar with what a proxy is, it's essentially a jump or a hoop to go through to get to another application. So what a reverse proxy is a loop or a jump that you must make through routing to get to your web server. So it's the reverse of a standard proxy. So instead of using it to go out, we use it to come back into our web server. So that should all make a little bit more sense as we go through this slideshow. Here's a URL, so here's the domain, or where your application lives, that is then turned into an IP address that routes to your web server through the internet. And then from there you get to the path that you want to go to on the web server and the file name that you want to get from that web server. So here's a simpler drawing of this. We have an HTTP request that comes in through the internet. So then here's where all of the routing is concerned to our web server, and then we have a technology that exists on our web server that can then understand the route that was given, and then it's going to serve back our HTML or CSS or JavaScript or Razor views, whatever they asked for. We then want to serve it up back to the web browser, and the web browser then takes that HTML and understands it and interprets it to display based on the web browser you're using. So Chrome, Firefox, Edge, Safari, etc. So let's go past some of this stuff, and then here's another drawing that shows the web server, this Kestrel web server. Here, it's essentially a reverse proxy that then goes into our application server, or ASP.NET Core. This is where our application lives. Here, so this is where the routing would exist to get to our MVC application. And then even inside, now this all exists inside our ASP.NET Core MVC application now, where you can see this HTTP request come in, and then it knows which controller to route to based on the route we give it in our URL string. So if we go to, for example, I know Google likes to use like calendar.google.com or gmail.com. Essentially, when they use that routing, it can then route to a controller. I don't think Gmail is probably written in .NET Core. I think Gmail, all the Google stuff, I think is written in Python or Ruby, so it's not a great example for this. But when we get to the routing, it should make a little bit more sense. But essentially, it routes to your controller, and then from there, we've already done stuff in our controller to where we know that that has a relationship to a model that we want to grab. So then we use the database server to be able to get those rows, or we're going to learn we can use Entity Framework to then serve up that model. We can then populate the model or the view model, which then routes again through the controller, and then it returns back a view to return to our web browser. So then there's usually a model embedded in our view that we populate our model from the database, and then the controller then knows about that model, and then we can then pass that model into the view from the controller. So if we're doing a GET request, for example, we want to get index, and then that index view populates some sort of view model. We can then pass it to the view as a parameter that goes into our strongly typed view. Okay, so then skipping through a lot more of this. Here's another picture that kind of shows the overlap between ASP.NET and ASP.NET Core. We can see that both of them have an MVC sort of framework here, but .NET Core is usable on more than one operating system, as you can see here. Here's some more stuff that happens under the hood that we really don't get to see happen when a request comes in. Anything that happens between our request URL and our controller is considered middleware. So whenever I use the term middleware, what that means is a lot of the things that happen under the hood between the request and the controller. So anything that happens between there is considered middleware. So excuse me. So we have authentication middleware, authorization middleware, routing middleware. And there's a lot of other different types of middleware too that we'll encounter as we continue on. So registering dependencies, registering databases, database contexts, and things like that. So I think the last thing I wanted to go through for this was just the URLs. So here in the configuration, here's our startup class. And if we remember, that's where we register a lot of our middleware. So we want to add controllers with views. So that tells it to look for our home folder, which exists and has our index view in it, use routing, and then use endpoints. So that tells MVC exactly how to get to which endpoint and exactly what it should be looking for in the URL string. So, for example, so if we want to get the home index view, we want to use the default endpoint here, and then the default endpoint pattern is where we're going to have our URL, so google.com or our website.com, and then after that is going to be then the controller action, and then maybe if we have an ID or something, so maybe we're trying to get an ID for an item or a product. So then exactly what does that look like? So here we see our local host, so this is our website, http://www.microsoft.com/home/about. So here's where we start routing to our particular controller. So this is the home controller. And notice if it doesn't have anything after home, it assumes that it goes to index. So even if there isn't anything after localhost, so maybe this is just http://microsoft.com. Well, because it's microsoft.com and there's nothing after this, well then it's trying to figure out where to go. Well, the first thing it's going to look at then is after the slash, but there's not one. So then it's going to say, okay, well then let me go to the startup controller and figure out what default route they have registered. And the default route they have is the controller home and the index action. So one more level deep, we have our website again, microsoft.com or whatever our website domain is, /home. And then it knows to go to the home controller, but then we don't tell it exactly which action to perform. So it's going to assume then that we want it to perform this index action. Because that's, again, within our default route. So then we can also specify, if we don't want it to go to that index action, exactly which action we want it to perform. So we want it to go to our website, microsoft.com, or whatever our website URL is, /home/about, which will then go to the about action or the about route. So that's how we can tell our .NET MVC, .NET Core MVC application exactly how to route to different parts of our application. So you can see we don't want it to go to home, we want it to go to product, and then maybe we want to list all of the products, so we go to /product/list. And then within the product controller, there's probably something, an action called list, that then serves up a list of products or a detail for a product. So that's exactly how the routing works in .NET Core. So I hope that makes a little bit more sense as we move forward here. As far as routing is concerned, we'll cover routing in a much deeper sense, I believe, as the book continues on. I believe it's around chapter 8 or so. It's a whole chapter that just covers routing. This is just to get us up and running, to understand exactly how we get to our controller actions in ASP.NET Core MVC. So one thing I did want to mention is if we go back to this here, which one returns back? Okay. So we notice that we have an HTTP request that comes in. So this shows us how a web server processes a static web page, which is true. But one thing we'll also find is we'll use this MVC pattern to make websites or web pages, which is fine. That's what a good use case for this MVC pattern in ASP.NET Core. One other thing we can use this MVC pattern for, and what's commonly used for, is to make web services as well. So we don't have to return back HTML and CSS and JavaScript. We can also use this MVC pattern, and we do use it quite often in the real world, to make a web service. So what a web service is it just sits on top of a database, essentially, and then returns back data. So if you have a website that relies on a data source, and you want to decouple that data source from your website, you can stand up a web service that then serves up JSON or XML or something like that, and you can do that with MVC as well, and using those same routing concepts that we already talked about. So uh, if you have a list of products or something, like you run like an Amazon.com and you have a list of products, what you can do is have all those products that sit in a database. From that database, you can have a web server that sits on top of it, or a web service, that all it does is it gets data from that database, it turns it into JSON, and then returns that JSON to your ASP.NET Core web application. So in our particular use case, we return HTML, CSS, and JavaScript, but if you wanted to set up a web service using MVC, you could also do that, where we return back JSON. And if we open up our application, this is just our movies list application, we can actually see what gets returned in our controllers. So here's a home controller that returns an iAction result. And remember, with polymorphism, this can be anything that inherits or anything that implements this iAction result interface, which we can see could be a JSON result as well. So we can also return JSON instead of HTML, which we won't do for this class, but is another use case for an MVC web application, to just serve up JSON to websites or to anything else out in the cloud. So just another use case. It doesn't have to be HTML that returning. There's a lot of pretty good frameworks out there that we can use in .NET to do this for us, or to make it easier. One of them being NSwag or Swagger to do that. So if you're ever interested or want to ask me more about making web services, it's kind of outside of the scope of this course, but it is something we can do. If you look up here, NSwag, or you want to learn more about it. So if you look, NSwag is a Swagger open API used for .NET Core, Web API, written in C#. And then you can see here it returns back JSON or JSON schema to describe a RESTful web API. So if .NET Core is something you think is cool and easy to work with, and you want to use it for maybe your senior design project or something like that, you can use this MVC pattern to also make web services that sit on top of a database and that serve up data to web applications using things like this NSwag platform. So that'll wrap up this video covering routing in ASP.NET Core. And then, so future videos will cover more with routing in future lectures. So I hope you better understand .NET Core and routing to controllers throughout the rest of the course.